Now in this video we will talk about alkenes. Going straight forward, alkenes have a chemical formula of CnH2n, just like cycloalkanes, right? So the formula is CnH2n. So when getting an alkene, let's look at a little example. If the number of carbons is 2, we have C2 and H2 times n. So 2 times 2 will be 2, which will be 4. So this particular one is an alkene. Okay, when the n is 3, also C3H, 2 times 3 will give you 6. So this is also an alkene. And now, an alkene, the most important thing, an alkene has a double bond. A double bond, so carbon to carbon, double bond. And they are not saturated, because saturated carbons actually have just single carbon to carbon bonds. Okay, now looking at the nomenclature of alkene, it's similar to alkanes, but the only difference is that it ends in ene instead of ane for alkane. So alkane is actually ane, but alkene will be ene. So when we have like propane for alkanes will actually be propene. And in naming it, the longest carbon chain will have to contain the carbon to carbon double bond. That is it. So if there's no carbon to carbon double bond in the longest chain, then it cannot be the parent chain. That is it. Now, looking at an example in this particular structure, we will have to look at the parent chain. Now the parent chain here will be simple: 1, 2, 3, 4 carbons, which is the prefix will be but. Because it's having a double bond, which is an alkene, it is actually going to be in. So butene, that is the name of this one. So this is actually butene. That is it. And with this, the parent chain will be 1, 2, 3, 4, 5, 6, which is a hex, which is actually a hex. So hex, so it will be hexene, right? But with this, the double bond is actually on the second one, between the second and then the third. So you pick the second one. So if it is here, you have to specify that the double bond is actually on the second one. So in specifying, this will be 2 hexene, right? Because the double bond is on the second carbon, it's attached to the second carbon. Okay, so this is 2 hexene, or it can also be named as hex 2 in. It's all the same thing. It is the same thing. Now let's look at a work example concerning this. Now don't be alarmed with this. It is the same thing. There is no difference in it. So you have to find the parent chain in this. So the parent chain in this is actually 1, 2, 3, 4, right here. 1, 2, 3, 4. Now after finding where the substituent is here. This is a methane. Okay, sorry, this is a methyl. This is a methyl right here. So this is actually going to be a 1, 2, 3, 4 will be a butene, right? Be a butene. Specifically on the second one, the double bond is on the second one. So this is a 2 butene, right? And there's a methyl, which is 1, 2. So on the second carbon, which will be 2 methyl. Okay. So the name of this particular compound will be 2 methyl 2 butene. Very simple like that. Or 2 methyl butene. It is all the same thing. Okay, looking at the second word example. Okay, now don't be scared with this as well. This is you find the parent chain here, which is 1, 2, 3, 4, 5, 6. Let's try another one. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Now they are all 6, and you have to take the one you will be conversant with, but I will be cool with 1, 2, 3, 4, 5, 6 right here. So if I choose this one, these two are going to be substituents. So fortunately, these are methyls. Okay, these are methyls. So where do we start naming from? You have to start naming from where the double bond takes a lower position. So the double bond here, naming 1, 2. We'll take 2 from here, 1, 2. But naming from here, to take 1, 2, 3, 4. which will be 4. So we start naming from here actually. So 1, 2, 3, 4, 5, 6. Okay, now we have a 2, so 2 hex in, because the longest carbon chain is 6, 2 hexene over here, and we have 2 methyl right here, and looking also we have 5 methyl. So the 2 methyls, combining them, will be 2,5 dimethyl. So the name of this particular compound is 2,5 dimethyl, okay, 2 hexene, right? 2 hexene. Yeah, so this is the name of this particular compound. Simple as that. Or it can be hex 2-ene. It's also the same thing. Okay, looking at another example, this is a cycloalkene, just like cycloalkene. So with this, the longest carbon chain here, 1, 2, 3, 4, 5, 6. Okay, so this is a hexene, right, with 2 methyls right here. And with this, you'll have to start counting from the double bond. So where do you start counting from? You start counting from 1, 2, 3, 4, or 1, 2, 3. We take the 3 instead of the 4. So here we start 1, 2, 3, 4, 5, 6. Okay, so we have 3 methyl and we have 5 methyl right here, right? So in naming this is actually going to be 3,5 dimethyl, because there are 2 methyl substituents. Dimethyl, I'm continuing from here, 1 hex in, okay, or hex 1-ene. It's the same thing. You'll be given the same thing. Okay, so looking at another example for this particular one. Now with this, there's an alcohol in this particular alkene. Now when there's an alcohol and there's an alkene, take note, when there's an alcohol and there's an alkene, the alcohol takes the priority. So you start naming from the alcohol, or you start naming from where the alcohol will take a least position. So from here, the least position will actually start from the alcohol, because this is a cycloalkene. And then ending of an alcohol, OL, or. So this particular one will be 1 or. Okay, so we start counting from here, 1, 2, 3, 4, 5, 6, right from here. Now the alkene is actually 2 hexene, okay, because it falls on the second one, and there is a methyl here, so this is also 2 methyl. So the name of this particular compound will be 2 methyl, okay, 2 methyl 2 hex in 1 or, okay, because of the alcohol or right here. And now looking at this, okay, looking at this one, alcohol also, you start naming from where the alcohol will take a least position. Now alcohol right here, you have to start counting from here. 1, 2, 3, 4, alcohol will be 4 here, but counting from here, alcohol will be 2. So 1, 2, 3, 4, 5. Okay, now we have 2 or, okay, and we have 3, so this is pentene, so this is 3 pentene, and there's a methyl group here, which is 4 methyl. Okay, so naming this, it will actually be 4 methyl, okay, 4 methyl, 3 pentene, continuing from here, 2 or. This is very simple. This is very, very, very simple, right? So 4 methyl, 3 pentene, 2 or. That is a very simple one. Let's take a last work example. Now with this, where do you start counting from? The double bond is here, there's no alcohol, so we start counting from 1, 2, 3, 4, 5, 6 right here. So we have 1 hex in, okay, we have 2-methyl right here, 2-methyl, and this is a tet butyl. So the tet, okay, sorry, 1 2 3 4 right here, 4 5 6 7. So this is actually a heptene. Okay, a heptene. So this substituent to be 4 tet butyl, right? 4 tet butyl. So naming this will actually, so tet butyl B will take preference to the M. So this will be 4 tet butyl, okay, 2-methyl, continuing from here, 1 heptene. Okay, so this is actually very simple. Thank you for watching this particular video. See you in the next video as we talk about alkynes.